All right, this is the answer key video for the lesson 8.1 and 8.2 practice problems. Okay, so again here in 8.1, if we start off here, we're looking at the price per pound of gravel, where X is the number of pounds and F of X is the total price. Okay, so again, as you noticed here, I underline while I'm going through the problems what is the most important, because really the rest of this is just extra information that sometimes confuses us. So again, if you're like me, just underline what are the main things, what do you actually need to know. Okay, now as a reminder here, this is all about linear piecewise functions. So we're the entire time using this y equals mx plus b equation. All right, so y equals mx plus b. B is your y-intercept and m is your slope. Okay, also known as your rate of change. Okay, then what you should notice here is you have a piecewise function and you have three pieces or three different rules. And again, when do we use these rules? Well, that's what these if statements are telling us. If our x value is between these and these, then we're going to use this. If x value is something like this, then this. If this, then this. Okay? So for the first one here, for values between 15 and 20. Okay, so that means we're right here. Between 15 and 20 falls between 0 and 50. So we're using this function. Okay? Now it says, what is the rate of change? That is your slope. Well, if you write y equals, since f of x is equal to y, right? Y equals mx plus b. Well, we don't have a b value, so our slope, though, is our rate of change, which is 10. Or $10 per pound, since it's the price per pound. All right. Number 2 or 92. Okay, a contractor wants to buy 150 pounds of gravel. So that means X is equal to 150. And again, that comes right here from the problem. X is the number of pounds. So if you're not understanding what you're reading, you're going to get yourself confused later on here. All right, but X is equal to 150. So that means we now have to use this second piece of the function because this says if X is greater than or equal to 150. So since we're at exactly 150, we're going to plug that in for our X value. 6 times 150 is 900 plus 10, we get 910 as our output value. Okay? Number 93, okay, this is the one where you have to say if blank, then blank. So if we purchase less than 50 pounds of gravel, then it costs $10 per pound. If we buy between 50 and 150, it costs $8 per pound plus an $8 fee. If we buy 150 or more, then it's going to cost us $6 per pound, but now a $10 fee. Okay? So again, whatever words you want to use, but you're just asked to describe the function. All right, now, number 94 here. Lots of information, but main thing is these are linear functions. So again, we're using y equals mx plus b, and a linear function has a constant slope. And again, to calculate slope, that's change in y over change in x, or y2 minus y1 over x2 minus x1. So in the first question here, find the rate of change for each table. Well, the slope for table A is the change in y, which between these two values is 2, over the change in x. So same values, that's a change of 1. So 2 over 1 gives us 2. Then down here, because it doesn't matter since it's all constant, change in y is 1, change in x is 1. So for table B, 1 over 1 gives us a positive 1. Now with 95 here, okay, what are the functions that can represent the data values in each table? So basically, what are the y equals mx plus b equations? Well, right off the bat here, we should notice that that slope is 2. All right, so therefore, since that's 2, our equation for table A should have y is equal to 2x plus something, potentially. Okay, so we can immediately cross off C and D because they have slopes of 1/2, which don't match up. Then we're left with option A and option B, and the difference between them is the first one is 2x and the second one is 2x plus 1. Same thing here, table B, they both have a slope of 1, but one has a minus 1 and one has a plus 1. So how do I find out these equations? Well, what we can do here is we can take our y equals mx plus b. We can pick any coordinate. So again, I circled the ones I picked. This is 4, 8, and 5, 4. All right. Since I picked those coordinates here, what I can do is I can plug this x and y value into the corresponding spots, x and y, and then I can solve for my b value. And in this first one for table A, I got a b value of 0, okay? So again, 2x plus nothing. Theoretically, I could end right there, but just in case we go all the way and we finish question B as well, or table B as well. When we do this, we get a -1 as our b value, or a -1 as our b value. So that confirms that we're looking at option A there, okay? Then for 96, use the table and the choice up here to write a piecewise function. So again, even if you're wrong, you need to use this down here to write your piecewise function. And the only thing that we're missing are the back end of those, which is our if statements. If, what about x? So this, our x values go from 0 to 4. So how do we write that? 0 to 4, and since we are including points at 0 and 4, we also write the including lines underneath. Same thing for table B. We're going from 5 to 9, and we include points at 5 and 9, so 5 is less than or equal to x, which is less than or equal to 9. Okay? And then we take our functions from the answer above. All right? For the next one here, okay, no, the answer is no. This is not the only possible way we could write this function. We learned a bunch of different ways that we could write this, okay? And also, just to give you a really quick example, okay, we could have changed this first one into just up to 5, but not including 5. Right? Because we're not actually told if this function ends at 4. We just know it doesn't start at 5. Same thing. How do we know it ends at 0? It could go beyond 0. Or how do we know it ends at 9? It could go past that. So again, there's multiple ways of writing this depending on what information we possibly have. All right, but in this answer, you could just say no. Number 98, okay, we're looking at, in this piecewise function, again, let's underline it together, an airplane starts to descend, to land, which means it starts going down, okay? Piecewise defined function where f of x represents the altitude after x minutes of descending. So again, lots of information, but underline what's important to you. All right, 98 says, what's the rate of change for the function when x is between 0 and 5? So again, between 0 and 5 pops us up here at that function. Now, what we're looking for is the rate of change, which is also our slope, and that is the coefficient that is out in front of our x variable. So here, and again, remember, if we're not using it, we don't look at it. So it's not a positive 2,000, it's negative 2,000. And what that means is the plane is going down at 2,000 feet per, not second, sorry about that, per minute, right there, because it says minute. Okay? All right, then for number 99, what's the altitude of the plane when x is equal to 8 minutes? So that pops us down to the second function because 8 is greater than or equal to 6. All right? And again, altitude is f of x, and f of x is y. So we're just solving for here when x is equal to 8. So we pop 8 in there. We do that multiplication. 18,000 minus 12,000 tells us we're at 6,000 feet. All right. Then number 11, after how many minutes does the plane land on the airstrip? So based on the answer above, okay, the plane at 8 minutes is still at 6,000 feet in the air. Okay, so it's going to take more than 8 minutes for us to land. Therefore, that means we have to use that second rule again. And if we're landing, that means we are no feet in the air. So f of x, which again is y, is equal to 0. Okay, so we take this function, right, and we set it equal to 0. So 0 is equal to 18,000 minus 1,500 x. Okay, so then we solve for x. Subtract 18,000 on both sides, divide both sides by negative 1,500, and we get x is equal to 12. So what does that mean? It's going to take us 12 total minutes to land. Okay, then lesson 8.2 here, okay? So lots of information, and I tried to color code it for you, okay? But basically, you're being asked to write piecewise functions from lots of different things, okay? So first off here, again, you ignore everything else that you're not looking at. So if we're looking at this blue line here, ignore the red line for right now, okay? Both of these, since they are straight lines, and again, everything in this unit is a straight line. Y is equal to mx plus b. All right, so in this straight line function here, y is equal to mx plus b. We do know where we cross the y-intercept, and that's at b is equal to 3. All right, then from there, we have to solve for our slope. So you're going to pick 2 points on your line, and it's change in y over change in x. So we go up 2, then over 2. Or you could have picked a point here, up 1 over 1. Regardless of what you pick, as long as you count them correctly, it should be 2 over 2 or 1 over 1, which gives you a positive 1. So that is my slope. Now we have to figure out, when does this actually occur on the graph? Well, if we drop this line all the way down, that's at x is equal to 2. But the slope or the line is going to the left. So it's actually not at x is equal to 2, but it's at every value when x is less than 2, right? Because that arrow is pointing to the left, which means less than. Then on the right graph here, we now ignore the blue. So for this one, we can't easily see our y-intercept, but what we can do is we can calculate our slope. So again, down to right 1, which means a negative 2 for my slope. Then what you can do here is if you don't have your y-intercept, we can solve for it because all of these points on this line fit with this equation. So what we do is we pick some xy coordinate. Okay, I picked this point 3, 3. You could also pick this point here, 2, negative 1. All right, but regardless, when we do this here, okay, we will see that we plug in our values, negative 3, positive 3, we get a negative 6, we move that to the other side, and our b value is equal to a positive 3. Okay, so that is our full equation. We pop that back up there, all right, and we get y is equal to negative 2x plus 3. Then we have to figure out, when do we start this function? When does that line take over? Well, that happens when x is greater than, since it's pointing to the right, or equal to, since it's a closed circle, a positive 2. Okay? Then to make your piecewise function, you just put them both together with a curly bracket and an f of x. Okay? Same thing down here. Blue function, red function. We look at the blue one first since it starts on the left. Okay? And we can figure out our y-intercept is at 1, and we go down 2 and right 2, or down 1 and right 1. Regardless of what you do, you're going to get a negative 1 slope. Then we have to figure out, when does this start? Well, we cross and have our point at x is equal to 0, and it is a closed circle, so that is included at 0. And since our arrow is pointing to the left, is x is less than or equal to 0. All right, then we cover up the blue function. We look at the red function. And again, this one's nice and easy because we can visualize our y-intercept. It's at negative 4. Then we have to figure out our slope. So again, pick any 2 points on the line. We go up 1, right 2, which is a positive 1/2. So that's our final expression. Y is equal to 1/2 x minus 4. Then from there, we have to figure out again, when does this take over? Well, it starts when x is at this 0 point, but we can't include it since it's a closed circle. But since it's going to the right, x is greater than 0. Again, we combine them with a curly brace and an equal sign of f of x, and that's our piecewise function. Finally here, okay, if we look at our blue function first, okay, what we can notice here is it is a straight line. Okay, it's just going straight left and right. Okay, so if we look and try to calculate our slope, up 0, right 1, well, 0 divided by 1 gives us a 0, which means we don't have a slope. But what we can do here is we can take that line and we can extend it to the right to see where it would cross that y-intercept. Or sorry, where it would cross the y-axis and give us our y-intercept. And that is at the value of 2. So with our 0 slope, 0 times x is 0. So this is just y is equal to 2. And when does this function take place? Well, when x is at negative 3. But also, since it's pointing to the left, it's less than. So when x is less than or equal to negative 3. All right? Then we take the red line here. Okay, where does it cross the y-intercept? Or sorry, where is the y-intercept? Okay, that is at negative 4. So y equals mx minus 4. Then we have to figure out our slope, up 1, right 1. So y is equal to 1x minus 4. And again, when does this start? Well, it starts at x is equal to negative 3. But it's not included, so it is when x is greater than negative 3. Okay? So again, combine them with a curly brace. F of x is equal to both pieces of your function. Okay? Then moving on down here, felt is sold from a textile manufacturer. Okay, so we're using this expression here. All right, then it says, consider the function that represents the cost of buying less than 20 yards of felt, where C is the cost in dollars, also known as the price, and L is the length in yards. Okay, which of the following correctly describes this function and its domain and range? So again, what we have to understand here is L is length of yard. So we're looking at there, okay? And the price, right, is our function. Okay, that's our function. So we are looking at less than 20 yards. So we're looking up here, okay? And if we look to write a function for this, this is 15 plus $4 per yard. So 4 times L, since L is the length in yards. So immediately we can cross off A and B because those don't match up. Okay? Then we can look at the domain and range, and we have to look at the domain and range. So this is saying the set of L when L is between 0 and 20. Okay, and again, our domain is our X value. That is what we're inputting, right? I'm going to buy or input 20 yards of felt. My output is the price or the cost. Okay, so here we're looking up at the felt purchase. So I'm purchasing less than 20 yards. Okay, so that's going to mean that that is my domain, and my final answer is the function at D. Okay, this here is expressing the range. So again, that's incorrect there. Potentially, even the range. All right. 105 says write a function to determine the cost of buying 20 yards or more. So we're looking up here. So it's 3.5 per yard. So it's just C of L is equal to 3.5 L. Okay. What's the domain and range? Well, the domain is how much we're buying. So we're buying more than or equal to 20 yards. So X is greater than or equal to 20. Then for the range, that's our output. Okay, so what we do here is we say, okay, if I buy the most possible, right? If I buy the most possible, if I buy the least possible, sometimes you can do the most, but for this one, if I buy the least possible, if I buy 20 yards, okay, 3.5 times 20 is 70. So that's saying if I buy the minimum number, if I only buy 20 yards, it's going to cost me $70. But if I buy more than 20 yards, it's going to cost me more than $70. Okay, so your equation there or relation is y is greater than or equal to 70. Because again, if I buy the minimum amount, it's going to give me at least $70. Okay, 106. Jen needs to buy 45 yards of felt for a school play. She makes a table of different methods she could purchase. Okay, what should she do? Well, this one's kind of silly here. All right, well, the cheapest price per yard is when you buy more than 20 yards, right? It's $3.5 versus $4 and this $15 fee. So why would she not just purchase it all at once? Because that's going to give her the cheapest price per yard. Okay. Number 107, write a piecewise function. Okay. That can be determined. That is basically putting those first two things together, right? So here's function 1, and that applies if we buy between 0 and 20 yards. Then this was our second function if we buy 20 or more yards. Okay, and again, we connect them with a squirrely brace, an equal sign, and our function. This one was C of L. Usually it's F of X. Okay, and last group or last page here. Okay, so we're looking at age groups versus prices for admission to a play. What is the range of the function where P of A is the price as a function of age? So function of age means that's your domain. Okay, so our range is our Y values, which is our output values, which is our price, which is our P of A. Okay, so what are the possible prices that it can be? 0, 15, 25, and 10. All right, if we look here, this is saying that we go from 0 to 25, but we don't include 0 or 25. Well, that doesn't make sense because right here it's 0 and right here it's 25. Okay, then if we look at C, 0, 17, 64, and 65, those are just possible ages. Okay, so that doesn't match. And then D is saying from 0 up to 65, not including either one of those numbers. Again, that's looking more at the age group than it is the price. Okay, so that would be our answer. And what I want you to note here is we had to move the $10 because when we write them, right, we write lowest to highest. Okay, so don't let that freak you out. They might be out of order, quote, quote, from this table, but to be in order, you go from lowest to highest. All right, then for number 109, write an inequality that shows our domain, which is, again, our age of the function, okay? And again, it says assume that the oldest person will be under 100 years old. Okay? Will be under 100 years old. So, what we can say there is 0, right? Because we got to be greater than 0. We can't be not 0, right? That would mean nothing. That would mean you're unborn. Up to 99. Or you could also, or up to and including, 99. Or another way of writing this here, because again, you can go up to, but we can't be 100. 0, A, less than 100. Okay? You less than 100. You can be 99 because that's under 100, but you can't be 100 years old. So either one of these would be acceptable, correct answers. And then 110 here, okay? Write the piecewise function that gives P of A as a function of age. So this one's really nice because it's just one price. And what we're really focusing on is our if statements. If, what about the age? So children 5 and under are going to cost $0. So the price will be 0 if their age is less than or equal to 5. This one, kids 6 to 17 will be $15. So the price will be $15 if their age is between and including 6 and 17. Then if you're an adult, 18 to 64, it's going to cost you $25. So the price will be $25 if you are 18 to 64 and including both of them. All right. And then finally, if you're 65 and older, it's going to cost you $10. So the price will be $10 if your age is 65 or older or greater than or equal to 65. Okay. So that's it. Okay. The answer key is posted. So good luck. Let me know if you have any questions. Thanks, guys.